Hello. Unit vocab. 20 words coming your way.
He's Monaco.
And that guy's Milks.
Ooh, vocab.
Vocabulary.
I will be able to understand some words and take a quiz.
Yes, sir.
Does that sound about right?
That's about right.
All right.
I love this gift. It's great. You just...
I couldn't help it.
It's great. Lovely, lovely stuff. So,
Right.
the first word of the day is
A word you think you know.
temperature, which is a word you do know. However, you don't know that it's actually a measure of the average kinetic energy of a sample of matter. That's what it is.
That's the truth. Heat transfer. This is heat going from one object to another. It always goes from hot to cold. It will never go in the reverse. We will actually be able to discuss that there's no such thing as cold.
Surely, right? Surely true. Now, kinetic energy is a great graph to show both potential and kinetic, but kinetic energy is itself simply the energy of motion. And with chemistry, we're talking about the energy of atomic motion. So atoms and molecules moving at the atomic level that you can't really see, but you can actually see. Ask and I'll show how I can demonstrate the fact that atoms are truthfully in motion all of the time.
Nice. And then same picture, so I don't need to let it go all the way to the end. We got to see what happened last time. Potential energy now is energy of position. And so for us, it's kind of going to end up being phase change.
Energy of phases, position of atoms within space. Sure.
Yes.
Kinetic molecular theory, well, this image is describing it, although you don't really understand or see that. You just see particles bouncing around. These are 5 postulates, which we'll teach in the lectures, that describe the behavior of gases. Gases behave in extremely predictable ways, and the kinetic molecular theory is the list of their behaviors.
All 5. Yep. Absolute zero. So here, this picture's good, right? Oh,
No, well, they're moving.
and then they're not.
Okay.
That's literally it. So this is the theoretical temperature where all motion stops, 0 heat energy, therefore no kinetic energy, therefore no motion.
No energy at all.
At all. And so we're really close to this. We are at what, 0.4 kelvins we've gotten to?
Within a few billionths of a degree, to be entirely honest. However, not attainable.
Yeah, not attainable yet. It's theoretical. Reference table.
Normal boiling point. This is a fancy term to describe the normal temperature at which things boil on the stove at home. And normally, water boils and things boil when their pressure reaches 1 atmosphere, so 1 ATM.
Right, because the atmosphere, that'll be the normal pressure.
Correct.
Standard temperature and pressure. Cooling curve. This is us tracking things as they get colder. Graphical representation of the kinetic and potential energy as a substance is cooled.
Facts. Heating curve is the exact opposite,
It's a
but the same.
Better
Same, but different. It's
Yeah.
how the energy
Better
phases
picture.
change as you heat up a sample from its solid phase all the way through its gaseous phase.
Yep. There you go. Evaporation. This is where liquid goes into vapor, specifically at the surface. So when the surface of a liquid changes into the gas phase. Liquid definitely does not evaporate from the bottom up.
Unless you're heating it, which we call it vaporization and not evaporation.
True.
Weird stuff. Same thing. The heat of fusion. Well, heat of fusion is a fancy term for the specific amount of heat needed to completely melt a solid without a change in temperature. So heat of fusion, melting or freezing. It's the same temperature, the same amount of heat is involved.
Yep. One's heating, one's cooling.
No change in temperature, heat of fusion, the amount of heat needed.
Sure. Vaporization we'll see is at a different spot. Same picture, different spot. So vaporization is the amount of heat needed to completely evaporate a gas with no change in temperature. And in the reverse order would be to condense that gas. But again, during the phase changes, no change in temperature. Big deal.
The overall heat of a chemical reaction is the difference between the amount of heat of the products and the amount of heat of the reactants. So we have an equation, delta H, aka amount of heat of the products, minus delta H, aka amount of heat of the reactants, shows a overall change in the amount of heat that the reaction is involved. So if the reaction absorbs heat, it would absorb it from the environment and it would feel cold. If the reaction releases heat, it would give off heat to the environment and it would feel hot.
Correct.
So the heat of a reaction is something that you can feel very commonly. We're just going to start to put numbers on them.
Yeah, and that delta sign means change.
Yeah.
We didn't know that. So melting point, check it out. Gallium.
Yeah.
I'm gonna let it play for a minute because it's gonna wait. That's a maybe.
It's melting.
Maybe just this hand. This is the temperature at which a substance changes from the solid to the liquid phase, or a liquid to a solid.
They're the
freezing point.
Same temperature. They're
Just
the
am I
same
heating
point.
it or am I removing heat?
Which direction is the heat traveling in? Away or into?
There
So
you go.
vapor pressure, aka pressure, is the pressure created at the surface of a liquid as the molecules push up on the atmosphere to try and become from a liquid to a gas.
Nice.
A few more, yeah.
Oh, yeah.
Mhm.
This is a picture of a bomb calorimeter,
Yes.
and calorimetry is just a measure of heat. So calories is a form of heat, and we're going to measure it.
This is some liquid boiling. I think there must have been something dissolved in the liquid because there's something that showed up in there.
What just
Well,
happened? There we
The boiling point / condensation point is the temperature at which a substance changes phase from a liquid to a gas, or vice versa, gas to liquid. Like Milk said, it's just depending on whether heat's being added or removed.
go. Which way we go? Ideal gas behavior. There's some particles of gas in a closed container moving around. This is when a gas is at high temperature and low pressure. They will obey the kinetic and molecular theory better. Remember that high temperature, low pressure. That'll be a key one to remember this year.
Absolutely. This is the combined gas law. It's an equation. It's a equality, if you will. So before and after scenario. It combines three gas laws, Charles, Boyle's, and Guy-Lussac, into one larger expression. And it's not that hard to work with once you understand your algebra.
Yes, and I'm glad you got that because I hate saying his name. I'll do standard temperature and pressure. This is on the front page of your reference tables. STP is just the temperature of 0 degrees Celsius in 1 atmosphere. Provides a standard set of conditions for us to make comparisons between experiments.
On different parts of the planet. Thanks for watching. We did that quick. Maybe you'll have to watch it twice.
See ya.
See ya.
Woo, okay.
Where's my button to turn this off?